And I think everyone here has to see if you get a notice asking for permission. Did it ask you?
I think it's only if you're not the host.
Okay, well, I'm just letting you, so I'm going to let you know now. Sometimes it asks for permission, sometimes it doesn't. We're going to be recording this, so keep that in mind. Feel free to stop me and ask questions. That's not a problem. But I just want to be able to post this when we're done. Did Leah hop in here? Hey, Leah.
Hi.
Okay, so here we go. Let's talk about the skeletal system. We'll spend about 15, 20 minutes, and then I'll let you guys go enjoy the rest of your day. But the reason two systems are talked about in the same unit is because they are intimately connected. You have muscles that are connected to your bones, literally, through tendons, but you also have to have one in order to use the other effectively. So we'll start with the skeletal system. When you are born, you have 270 bones that are pretty soft and pliable. That makes it for a much easier exit out of the womb. And it keeps you from crushing your bones as you exit. And as when you're a very, very tiny baby, you need that flexibility just in order to, again, maneuver your way out. And then it doesn't take long for this ossification to occur. But as an infant, you had 270 bones. Then the bones start to harden and actually fuse together. Now, as you guys now, all of your bones have gone through the ossification process, but you still have cartilage, which is the floppy stuff that you can easily feel. Your nose, tips of your nose, and your ears are exceptions to that ossification. Those are still cartilage. So as you've grown and you guys are here now, you have about 206 bones total. A lot of that's just because your bones fuse together. So you're probably familiar with the pictures of the skull, like an infant skull versus an adult skull. But if you're not, you can see on page 419, I'll show you this. Can you guys see this? But this page here in your textbook shows images of the skull and how it looks initially when you are born, and then how it looks as an adult. And there's a progression as you mature and develop that your skull goes through. And again, that's on page 419. But that's just one example of how you go from multiple bones to one. And so now your skull, the back of your skull is really considered one with fissures all around it where all those separate bones used to be. But even in that picture on page 419, on that far left picture, you know, like if you talk about how a baby's head has a soft spot, have you ever heard that term? That term is, what that means is there's literally not bone covering that one spot yet. Again, that was to allow you to exit as easily as possible from your mother, and then the ossification process could begin. All right, so this picture next is a lot more detail than what the book shows. So I don't want you to memorize the skeleton. That's not what I'm asking you to do. What I want you to do, though, is if you have your textbooks handy, look on page 416. If you don't, make a note that that's where the skeleton is on pages 416 and 417 in your book. And on page 416, you just see the frontal view with the few pullouts there that they've emphasized. And then you see the back view on page 417. You see the top of the skull, and then you can see the profile view of the skeleton as well on that page. I'm going to tell you some of the main bones that I do want you to try your best to learn the names of and remember them, just because they frequently get used in conversation, or you might hear them, you know, depending on maybe a movie you're watching or a TV show, or you're reading in a book. Main bones in the body that people tend to use, not just thigh bone, for example. A lot of times you might read or hear femur, Well, I want you to know that a femur is your thigh bone. So we'll stick with the major bones for this session, but I do want you to know some of the real names of these bones. Now, the skeleton is broken down into two main sections. You have the axial skeleton, and that is, in an adult, is 80 bones. So that is it in your textbook, again, just pointing this out. On page 416, it highlights the idea of the axial and the appendicular skeleton. And you can see that the axial skeleton on page 416 is highlighted in blue. So the words are in blue, there are blue dots that go along that page. That's your axial skeleton. So that's your midline of your body. So your skull, your ribs, your sternum, and your vertebral column are the part what makes up the axial skeleton. And then the rest of it is called the appendicular skeleton. So everything that sticks out, your arms, your legs, your pelvis, and your pectoral bones, that's the appendicular, so the add-ons. So you have your trunk, your center is the axial, and then the add-ons are the appendicular. And then we have different classifications. So you'll hear the term maybe long bones. Those are the bones, best examples in your arms and your legs. Those are the longer bones in your body. And then you have flat bones. So those are the ones that make up your ribs. And then we have short bones. I should say not one bone. Let's just say bones, not ones. Short bones. And those are the, and you can see in the pictures why you call them short bones is because they're so much shorter than the long bones. So the bones that make up the hands and feet, called the carpals and the tarsals, those are considered short bones. And then the fact that, think about your skeleton, and your skeleton is hard, most of it, except again, your cartilage areas, nose and ears. The rest of your skeleton is hard. So it's actually, if you don't have places where your skeleton comes together and meets at certain points, you would not be able to move your body. You'd be very stiff, kind of a Frankenstein's monster kind of image, if you think about that. You wouldn't be bending your elbows, you wouldn't be running, you'd be your legs would have to stay straight, etc. So there is some flexibility in your skeleton because bones come together at a meeting point, and those are called the joints. So it becomes somewhat common sense where the main joints of your body are, but we'll talk about those. But it's any place where two bones meet or three bones meet in some cases, and there's some flexibility to your skeleton. That's where your joints are. Now the reason, but at those joints, your body's not falling apart. So there are things in place under your skin that are keeping even though there's some flexibility at the joints, that's keeping those bones somewhat attached to one another. So those are the ligaments, which are made of, you think back to the very beginning of this anatomy chapter, we talked about ligaments and connective tissue. So ligaments are made of connective tissue. They connect things, kind of makes sense. And those ligaments attach to what we call the periosteum. Hold that. All right, and the periosteum is the bone's outer covering. And those ligaments are responsible for holding your bones together. So now, I know that some of you play sports, or you dance, or you do other activities, and when you hear sometimes of injuries, it involves the tearing of ligaments. So your knee, for example, has three main ligaments that kind of piece it together in between the lower leg and the upper leg. And you can do any number of damage to those ligaments, anything from straining it to tearing it. And depending on which ligament, it makes the injury more severe. So, in high school, I tore my ACL, in my knee, which stands for anterior cruciate ligament, which meant I had to have surgery. And I couldn't play sports for a while because that gives your knee a lot of stability. And without that ligament, if you were older, if I had been 60 or 70 and I had torn that ligament, it's not life or death. I might have made a different decision. But when you're young and you still are active and you want to exercise a lot, and you want to play sports and you want to not have to worry about whether your knee is going to shift out of place, it's important to have that stability there. So it was important to me to have that surgery. So it wouldn't have killed me, but I would probably be limping by this point and not having as much freedom of motion. So ligaments are important. You have ligaments though, not just in your knees, elbows, shoulders, basically where you have joints, you're gonna have ligaments. That could also get damaged, the sidebar. Now, if you again, let's see, look on page 416, you'll see this picture here. And I'm gonna come back to those notes in just a second, but you're gonna see a picture that looks almost identical to this. So here is what's going on inside a joint in your body. Now, it's gonna look a little different depending on where the joint is located. But you can see here that there's a big gap between the two bones. It's not empty, but there's not bone there. What you do have though is you have synovial membrane, you have some fluid, you have some cushion to keep your bones from grinding into each other. So if we go back to the notes page, it's not the exact same, but it's nearly identical to what's on page 416, that pull out from that's highlighted at the bottom there. So you have something, who is that? Hang on. Sorry, I'm letting someone in, and I don't know who it is because they've changed their name.
It's Caitlin.
Hi, Caitlin. All right. So you have something called the joint capsule, and that covers the ends of the bones that form the joint. The synovial fluid is found in those synovial membranes that line the joint cavity. And then you have these things called, let's go back, see if it's here. You have bursas. Now, the bursa is not actually labeled, but here, I can type this in for you if that will help. You have bursas, and they're mentioned in your textbook. It's just not labeled there. But bursas are, located between the moving parts of the joints. And they help to reduce friction between the bones. So a lot of times you'll hear, hi Dominic, of a condition called bursitis, if you've ever heard of that. And that has to do with the bursas that are located between the joints. And they help to provide some cushioning. So your joints themselves are able to absorb a lot of the shock that comes from movements, particularly in your legs. If you think about if you are a runner or you're an athlete, how much stress you actually put on your legs as you cut, as you sprint, if you're a long distance runner, the pounding that your knees are taking. Okay. You would not be able to walk or run for long if you did not have all of these things here to kind of cushion the blow. And that's what this area right here is for. Everybody doing okay so far? Any questions? All right. Now just quick, the joint is where the bones meet. The ligaments are that connective tissue. And I just put that in there twice to blow that up. But if you look here at the bursas, the point is this: you want to reduce the friction between the structure as they move. Okay. So that's why when someone has bursitis, it can be very painful. Because if you have an inflammation of that area, then it's swollen, number one. Number two, it's not able to do its job. And so you have to treat that area gingerly. All right, now, since we're talking about joints, there are a few types that we need to understand, and we're going to talk about a few examples. Again, you don't have to know them all. So, immovable joints. So going back to your skull. Remember, when you were first born, there was a lot of gap, a lot of separation so that you could be easily born. Your skull actually had to collapse a little bit so that you could come out of your mother. But that's really the only purpose in that. So you don't need all of those separate bones anymore once you're born. So over time, that soft spot that you may, if you've ever held a baby, you may have been told, oh, watch out for the head, watch out for the soft spot. Well, there is a point to that. There's no bone covering the brain there. There's like it's not a hole, but there's a gap. So you do need to be careful with that soft spot. But anyway, as you get older, those spaces fill in and you're left with it's still a joint, but your skull doesn't move and shift anymore. Okay, so those are immovable joints. And you can see those in a skeleton. You can see the sutures that are there where they come together and kind of solidified in place. Then you have pivot joints. And these are also on page 417 in your textbook. All right. So a pivot joint allows you to do this with your head, back and forth. All right. So the two top vertebrae fit together. One kind of is inserted into the other, and the lower is inserted into the upper, and that allows you to turn your head, to pivot back and forth. Then you have slightly movable joints, which gives your back some flexibility, but not too much flexibility. You don't want your back completely bending and breaking. All right, so you have those slightly bendable joints or slightly movable joints that allow your vertebrae to slide back and forth just a little bit with each other, but not as much as, say, your hip, which is the next type of joint. And these are, you'll see these in your hips and shoulders, where your arm connects to your shoulder bone. There, that ball and socket. So the ball would be the top of your arm, and your shoulder creates that little pocket. Same thing with your hip and pelvis area. So you have the pelvic bone, and then your femur that meets up with that. Top of the femur is like the ball. The socket is that divot in your pelvis. Now the hinge joints kind of make sense. If you think about a door opening and closing, that's how a hinge works, back and forth. Well, that would be your knee and your elbow, but also your knuckles. You can do that. That's because you have hinge joints there. And then the gliding joints, those are your wrist, or near your wrist and your ankles. That allows you to make all kinds of twisty motions with your wrist and your ankle. Sorry, Julia, what are you doing? I need 5 more minutes. Sorry. Okay. Now, I'm going to stop talking about this right now, and I want to go over the bones that I want you to know. So if it's helpful, you could do little tick marks in your textbook. And there's also the activity that I've posted. If you haven't done it yet, the homework for tonight is labeling the skeleton that I've posted online. Okay. And there's, if you've looked at it, I think there's 20. Has anyone looked at it? Madeline, did you look at it? You didn't look at it yet? Okay. All right. Pretty sure there's 20. But here are the ones that I want you to know for sure. So do a tick mark and a check mark in your book. That's fine. Just make it light. But I want you to know you could just call your head, the skull. All right, that's fine. Cranium is also fine. Some books actually will say skull, some will actually say cranium. I want you to know that your jaw is the mandible. Okay. Your collarbone is the clavicle. You have the long bone in your arm, the top long bone in your arm is the humerus. Then you also need to know the two smaller bones that are in your lower arm, but they're still considered long bones, but they're just shorter than the humerus. Those are the ulna and the radius. Your wrist bones are carpals. Know that. And then for your fingers and your toes, you can just know that those are called phalanges. Any questions so far? Am I going too fast? Then if you go to your leg, you need to know that the long bone, the longest bone in your body is the femur. That's the thigh bone. Your kneecap is the patella. You should know that. And then the larger lower bone in your leg is the tibia, and then the longer, thinner one is the fibula. So know that the bigger is the tibia, the outer, thinner one is the fibula. And again, and then your ankle bones, remember your wrist bones are the carpals, your ankle bones are the tarsals, and then you have phalanges for toes as well. All right, now that was dealing, except for the skull of the mandible, that was all dealing with the appendicular skeleton. Going back to the axial skeleton, I also want you to know, besides what I've already told you with the skull / cranium and the mandible, I want you to know your ribs. Okay, hopefully that's easy. And your sternum. Know that your hips are actually called your pelvis. Okay. And then just know that the bones in your back are your vertebrae. Okay? So the reason, so when you go back and look in your, as we finish up today, I'm going to hush, but that is just to show you how much more in detail we could go. Okay, I'm not going to have you memorize all those different descriptions. We could talk about all the sections of the skull if you wanted to, if we had time, but we're not going to. So this right here is how complicated it could get. We're going to stick to your textbook drawing. And I'm going to let Peyton, since I'm wrapping up. I'm going to stop biology for today. Do you have any questions? Okay. All right, so biology, you are welcome to stay on and learn some chemistry. If you have questions after this, then what I would like for you to do is come back around 12. If you want to ask me an actual question, I'm going to spend about 30 minutes with chemistry, guys. And then if you have questions, you can hop back on right around noon. I'll still be here. But your only assignment today is to label that skeleton that's on Google Classroom. Okay? So just hop back on in about 25 minutes if you have more questions, or shoot me an email or a note on Google Classroom as well. Okay? Thanks for coming, guys. It's good to see you all.
Thank you.
You're welcome. All right. Hi, Taylor.
Wait, Mom, what is the homework for today?
What?
What is the homework for today? Is it just that assignment? on Google
Just
Classroom?
labeling the skeleton.
Okay.
Is it, you see it? Is it, I did post it, right?
Yeah.
Okay.
Bye.
All right. See you later, babe. Did Taylor leave? All right.